So what we're going to look at next in regards to discrete random variables is how to find the mean and the standard deviation for a discrete random variable. So as we take a look at those two concepts here, the mean of any discrete random variable is an average of all the possible outcomes. And the formula that we're going to use to find the mean of a discrete random variable is this right here. And that is the sum of each x value times its corresponding probability. And sometimes that mean is referred to as the expected value. This is what we would expect to happen given the probability model that lists all its possibilities and the probability for each one of those possibilities occurring. So for something like this here, and this is one of the examples that we did from the previous lesson, we have here the baby APGAR scores that are from 0 through 10 and the probability of each one of those scores occurring for the 2 million babies that they sampled. So the question here says, compute the mean of the random variable and interpret it in context. So if we're talking about computation here, what we're basically going to do is we're going to take each of these probabilities and each of these values and multiply them by the corresponding probability. So I got 0 times 0.01, 1 times 0.006, 2 times 0.007, etc., etc., etc. And what I want to find is the sum of, and this Greek letter sigma here represents the sum of multiplying each of these values together. And that's how you find the mean of a discrete random variable, otherwise known as the expected value. So in this particular instance here, when I multiply all these values together and add them, the sum of this would be 8.128. That's what the value is. And then the interpretation of the mean would be this. We would say the mean APGAR score of a randomly selected newborn is 8.128. And we would say that this is the long-term average APGAR score of several randomly chosen babies. So just note here that the expected values is very important. Does not need to be a possible value of x or an integer. Because we're just talking about an average, okay, it doesn't necessarily have to be, like in this case, a whole number like these values are here. It is just a long-term average over many repetitions. So that's how you find the mean of a discrete random variable. The other thing that we're looking at with this is the standard deviation. So keep in mind that when we're talking about standard deviation, we're talking about the average distance that a value would be from the mean if we randomly chose it. So just remember as we come back to this here, not every baby is going to have an APGAR score of 8.128. Some are going to be above that, some are going to be below that, and the standard deviation essentially measures, on average, how much can we expect a baby's APGAR score to differ from 8.128. So in order to find that value, what we're going to do here is we're going to take the expected value and we're going to subtract each data value minus the expected value, and we're going to square it, and then we're going to multiply the corresponding probability for that. And when we do an example of this, this will make a little bit more sense here, and I'll show you a quick shortcut on how to do this on your calculators. So to get the standard deviation of the random variable, you want to take the square root of the variance. So this formula right here gives you the variance of a discrete random variable. The standard deviation would be the square root of that right there. So coming back to this example here, to find what the standard deviation would be, I'm going to take each data value, which in this case would be 0 for the first part. I'm going to subtract it by the mean, and I'm going to square it, and then I'm going to multiply by the corresponding probability. Same thing here. Data value minus the mean squared times the corresponding probability value. And I'm going to do that for each of the values that are in the probability model there. And then I'm going to take the sum of those products. And when I do that here, this comes out to be roughly about 2.066. So the interpretation for this would be, and that's the variance, here's the standard deviation, 1.437. Got to take the square root of that at the end. So the interpretation for that would be the standard deviation of x is 1.437. So we would say, in terms of an interpretation, that's this part here. On average, a randomly selected baby's APGAR score will differ from the mean, 8.128, by about 1.4 units. So that's the interpretation that we have for something like that there. So just some tips here involved with the AP exam, and I'm going to kind of get into some things with both the mean and the standard deviation in a real quick and easy way on your calculator. But when asked to calculate the mean or standard deviation of a random variable, students often lose credit for not showing adequate work or for not showing or for showing no work at all. So yes, there's a quick and easy way to do this on your calculator. I am going to show you that in a moment. But this whole ... business is really what you want to do when you go to do this in your calculator. Essentially, what you want to show is the first part of this, I think, would be good, and then maybe the last part with the sort of the ... in the middle. And what that shows is that you recognize how this is worked out. And then what you can do is from there is you can go right to your calculator and get the answer to this, which, like I said, I will show you here in a moment. So to get full credit, students need to go beyond just reporting the commands used on a graphing calculator. So just remember that not every student takes the AP exam with a graphing calculator. So one of the things that you don't want to do when you explain your free response question is to get into calculator speak. Like, do not do that. That's a big no-no. And then in the case showing the first couple of terms with an ellipse, that's the ... for the calculation of the mean and standard deviation is more than sufficient for something like that there. So checkpoint question here, and I'll give you a few minutes to do this on your own. And the question says, a large auto dealership keeps track of sales made during each hour of the day. Let X equal the number of cars sold during the first hour of business on a randomly selected Friday. Based on previous records, the probability distribution of X is as follows. So they expect to sell 0 cars with a probability of 0.3 in the first hour of a randomly selected Friday. They expect to sell 1 car with a probability of 0.4 in the first hour of a randomly selected Friday. 2 cars would be, probability for that would be 0.2. 3 cars, the probability for that would be 0.1. So take a moment and see what you can do with the mean and the standard deviation for this on your own. So to find the mean for this, what I'm essentially going to do here is I'm going to take each of these data values, I'm going to multiply them by each other, and then I'm going to find what the sum is. And if you do that, you get a mean of 1.1. So we would expect 1.1 cars to be sold during the first hour of business on a randomly selected Friday. That's the interpretation part for the mean there. So that was number 1. Number 2, the standard deviation comes out to be 0.9434. So in order to get that, what I'm going to do is I'm going to take each data value, I'm going to subtract it by 1.1 and square it, and then I'm going to times each of those by their corresponding probabilities. And when I do that, I get 0.9434, and the interpretation for that would be we would expect the number of cars sold during the first hour of business on a randomly selected Friday to differ from the mean on average by 0.9434 cars. So in terms of how you do this on your calculator, so let me kind of pull this out here, okay, and come back to your calculator. So what I want to do to get the mean and the standard deviation on your calculator is this. First, I want to go to Stat, I'm going to go to Edit, and I want to put, and this is the checkpoint question that we just did, so I'm going to put the X values in L1, and I'm going to put each of their corresponding probabilities down here in L2, and then to find what the mean and standard deviation are, all I want to do here is, from here is I want to go to OneVar Stats. So I'm going to go to Stat, I'm going to go to Calculate, I'm going to go to OneVar Stats, and then from here I just want to make sure that my X list is in L1 and my frequency list is in L2 now. That's something that's a little bit different than what we did before. Before we left the frequency list blank or put a 1 in there. Now I have the frequency list as L2. Now when I go to calculate this, here's the mean, X bar, so that's 1.1. And then here's the standard deviation. This is sigma X, 0.9433981132. So what I would suggest that you do, for instance, like when you're coming back to this problem here, what I would suggest you do when you go to do the mean for this is, I would do, in terms of like a free response type question, I would do something like this. We would say that the mean equals, 0 times 0.3, and then I would do the ... thing, and then I would say here 3 times 0.1, and then I would go right to this, because then you could use your calculator to get this. Same thing with the standard deviation for this. Okay, I would go, for this I would say, for the first part, we would say standard deviation equals, 0 minus 1.1 squared times 0.3, That's this part here. And then I would say dot, dot, dot. And then I would go to this part here and I would say plus 3 minus 1.1 squared times 0.1. And then you can say equals that right there, which you can get from your calculator. So that's one of the things that I think would be easiest for you to do in terms of a free response question in regards to your calculator. If it's a multiple choice question, you can just go right to your calculator. There's nothing really that you need to work out for that there. So one of the things that we'll look at next has to do with what's called a continuous random variable. And a continuous random variable typically comes from measuring something, where a discrete random variable typically comes from counting something.